Okay, so morning everyone. Today we're going to be talking about the final subtopic in our chapter 1 of Physics Form 5, which is elasticity. So the first three subtopics, which is resultant force, resolution of forces, and forces in equilibrium, these three are actually very closely linked lah. Dia ada kaitan yang sangat rapat. Okay, but this fourth subtopic, macam dia seperti satu bab yang baru, it's a new chapter. Okay, but we still have to learn it anyway, and it is the last part of this chapter, which is called elasticity. Okay, so the thing that we need to understand is what is the meaning of elasticity. Okay, that's our main aim for today lah. Okay, I want to talk about only 1.4.1 and 1.4.2 today. Okay, and when you see this word experiment kind, yeah, I think you kind of know why today there's going to be a lot of work lah. Okay, so but we'll get there. Okay, so let's talk about elasticity lah. This is a very normal case. So you have this guy who is rather black, and he walks and then he sees on the ground there is a stick and there is a spring. Okay, now fundamentally the stick and the spring, okay, have two very different characteristics. Okay, so the guy is like, what are you doing? Then you pick up the spring, and when he picks up the spring, you find, and with any spring, okay, when you tarik the spring, it will extend. Okay, so the official term, okay, perkataan yang secara rasmi is extend lah. Bila kamu tarik the spring will extend. Tetapi when you lepaskan the spring, okay, what happens to the spring after you let go of the spring? Will it remain extended, or will it go back to the original position? What do you think?
Go back to the original.
Okay, it will go back to its original position lah. But is there a case? Is there a case where if you tarik the spring gun and it cannot go back to its original position? What kind of case are we thinking about? If let's say you tarik and then it cannot go back to the original position, what kind of penarikan yang akan menyebabkan itu berlaku?
Kalau tarik kuat-kuat.
Ya, kalau kamu tarik terlalu kuat, if you overextend the spring, okay, the spring will not be able to go back to its original shape lah. Okay, I think was it your class kan yang saya cakap, like if you put too much pressure on something, too much tension on something kan, okay, then it cannot go back to the way it was lah. Oh. Macam life lesson pula kan. Okay, so you can put a lot of stress or a lot of pressure or a lot of force on the spring, okay, and the spring should be able to go back to its original position. Okay, should be able to. But if you over force the spring, okay, if you over force the spring, there's going to come one day where the spring is just going to say, hey, I give up lah. I don't need to go back to my original position. So just biarlah saya biarlah saya loose begitulah. Okay, don't have to go back to its original position. So when that happens, we say that the spring has lost its elasticity. Okay, and this is a very important thing. So when you press the plasticine with your thumb, right? Okay, this is in page 25 in your textbook. Okay, what will happen is the plasticine will become leper lah. Okay, sorry, I don't know what is leper in Malay. Flattened itu. Okay, so the plasticine will be flattened. But when you remove your thumb from the plasticine, we find out that it cannot go back to its original state. Okay, so remember we were talking just now, like for example, this spring or even a sponge, when you press the sponge, right, normally lah, okay, when you press the sponge, or when you pull the rubber band or you pull the spring, it will go back to its original shape, or it will go back to its original length. Okay, but in the case of the plasticine, I hope that you have enough experience with plasticine lah. Okay, when you flatten the plasticine, then when you let go of your thumb, okay, what happens to the plasticine? It cannot go back to its original position. Okay, it cannot go back to its original shape lah. Dia tidak boleh bounce back, so to speak. So we say that because of this, the plasticine is not elastic. Okay, so the meaning of elasticity is like this lah. Elasticity is the ability of an object. Dia punya kebolehan dalam satu objek to return to the original shape when the external force is removed. When you put a force, it will change shape. Okay, just like plasticine, sponge, spring. When you put a force, when you press the sponge will kempis lah kan. When you pull the spring will extend, okay, will become longer. But when you let go of the spring or you let go of the sponge, which is this one, the external force lah. Okay, so when you press on something, when you pull on something, kita mengenakan satu daya dari luar, the external force. When you remove the external force, if that object can go back to its original shape, then we say that that object is elastic. Okay, so in the case of the plasticine just now, the plasticine is not elastic because once you press it down, when you lift up your hand, it cannot go back to its original shape. Okay, and so this whole subtopic is exploring this idea of elasticity because we find that we use elasticity in a lot of things around us Okay, for those of you who are gym junkies, you will obviously have seen this stretch band before. Okay, or if you like diving, you know the dive board. Okay, is also elastic Okay, because it can come back to its original position. Okay, this is a very normal one. Okay, if you have babies in the house, you will definitely know this lah. Ini adalah yang bikin buayan bayi makan. Okay, go back. But you know, after a while, the spring on top here, it can lose its elasticity. Dia boleh kehilangan dia punya kekenyalan atau keelastikan kalau the bayi terlalu berat lah. Okay, atau kalau orang yang macam saya pergi sibuk-sibuk duduk di atas buayan tersebut. Okay, then the spring will become extra long and then bila saya berdiri, dia kendur sudah, it cannot go back to its original shape. Okay, so the poor baby, dia terpaksa tidur dengan spring yang rosak. Okay, another one is trampoline lah. Okay, I don't know how many of you have trampolines in the house, but I don't have a trampoline in my house, obviously. But I like trampolines. Trampolines are super fun. But the big trampolines, not the enough for one person is not fun. I don't know how many, I don't know, anyone of you got experience like jumping on like really huge trampolines? Wow, it's super fun. It's very stress relieving. Yeah. So, yeah. Maybe next time when you grow up and you have a lot of money, go and invest in a trampoline. Okay, then when you're stressed, you just jump around and punch the air or punch the wall to release your stress. Okay, but anyway, trampoline is another example of elasticity. Okay, and then of course we have things in the lab, okay, like the spring scales. Ini adalah skala spring. So all these scales, they use spring to, like ukur berat, ukur jisim begitu. Okay, so the spring inside the scale must be elastic. Otherwise, the scale will be rosak. Because every time you lift up something, the scale must go back to zero. So you don't want a spring that is not elastic inside the scale. Otherwise, kamu akan sentiasa mendapat jawapan yang salah. So, this is our main job for today, okay, which is this experiment. Okay, so I want us to discuss this experiment together. Take a look at page 25 in your textbook. Okay, page 25 in your textbook. Most of the things are there, but there is something that I need us to brainstorm together. Okay, so whenever you have an idea, okay, just unmute yourself and just, say it as soon as you can, especially the procedure, because if you take a look at the page 26, the procedure is not actually complete. Okay, so we have to figure it out over here. Okay, and this is good for us because nanti bila kamu SPM nanti, ada eksperimen makan. And part of the skill that you need to know is you need to figure out the steps yourself. Okay, so this kita anggap ini sebagai training training untuk kertas tiga. You have to know how to plan an experiment and you have to think it on your own Okay, of course now we have to do it in class because we're discussing, but train yourself to think. Jangan saja menunggu buku punya eksperimen punya prosedur terus kau ikut saja. Okay, we have to think. Okay, so this is the situation. Okay, so diagram 3.1, 3.2 show a father and son sitting on two identical bird nest swing. Okay, I have a very big fear of this bird nest swing. Saya selalu takut because I'm so heavy so I'm always afraid that if I sit on the bird nest swing saya akan jatuh di lantai like the spring will break Okay, so I have this horrendous, I have a very big fear of this kind of kerusi I just feel that no spring can support my weight no spring can support my mass. Okay, so it doesn't matter how strong the spring looks. Saya selalu tengok orang kan yang duduk di atas swing ini kan, tu saya kagum bahwa macam, oh so nice, oh they can sit like that. Okay, but saya betul-betul tidak berani. So saya takut nanti the thing will patah atau saya terbalik. which incidentally actually happened to me before. Tapi dia terbalik sebab ada orang tolak, but somebody pushed me from the back over here. Okay, then saya jatuh ke depan lah, and then the whole swing kind of like fell on my face lah. Okay, so yeah, I have this horrendous fear of this nonsense swing. Anyway, so the spring of swings, okay, are extended when set by them. Okay, so this is obviously the father because he looks older, and this is the son. Okay, take a look at how much the extension, okay, the extension of the spring. So extension dalam bahasa Melayu maksudnya pemanjangan. Okay, sorry, let me remind you again. The word pemanjangan maksudnya kita mau tahu berapa banyak dia menambah kepanjangan. Right, yeah. Berapa banyak dia menambah dia punya kepanjangan. Because when you tarik a spring, it will become lebih panjang bahkan. So how do I calculate the pemanjangan? Can anybody think about this? Let me know what you think. How do I calculate the extension? Saya mau tahu berapa banyak dia sudah memanjang. Anyone?
Measure the original state of the spring and after it extended.
Okay, so you measure the original state and after it extended, and then?
Minus it.
Okay, then you minus it. Okay, so original state of the spring, the original length, mesti kau ukur dulu lah. Okay, then lepas tu kau duduk, kau ukur balik the spring, and then you minus. And that's how we count extension. Okay, pemanjangan. Okay, saya tidak mau tahu panjang akhir tahu. Saya mau tahu berapa banyak dia memanjang from the original length. Okay, so the inference for this, we notice that the inference for this, and this is in your textbook, is that the force will influence or affect the extension of the spring. We notice that when the father is sitting down, the extension is bigger. Dia lebih panjang di sini. When the son is sitting down, the extension is smaller. They extend, tapi they extend kurang. Okay, so the force akan mempengaruhi the extension of the spring. And when we flip it around, the hypothesis will be the bigger the force, the bigger the extension of the spring. Okay, and once again, let's use the words the bigger, don't use longer. Okay, the bigger the force, the higher the force, the higher the extension of the spring. Okay, dia menjadi lebih panjang. And that's very logical lah kan. I think there is nothing so fantabulously new about this. It's very logical to us. When you put more weight, okay, on a spring, okay, it will become longer. It will become even longer lah. Okay, Ken, does that make sense? All right. So let's continue. So the aim of this experiment, which you are going to do over the weekend, is this lah, to determine the relationship between force and the extension of the spring. We want to verify that hypothesis. The hypothesis is the bigger the force, the bigger the extension of the spring. So because of that, the manipulated variable must be the force. Kita mesti ubah dia punya force. The responding variable will be the extension, bukan the final length. Okay, if you take a look at this gallery maklumat, it's in your textbook also lah, page 26. Okay, the English version is in your textbook. So the original spring, we call it as L0. Okay, if you can see this L0 over here. So L0 is actually it's not L0 lah, it's LO. LO means original length. Okay, manakala the L, this one, certain books now will write this as L new. Means after you put the force, okay, it will become a new length. Okay, so in order for you to count the extension, and we are going to use the letter X to represent the extension, it will be the L new minus the L original. Okay, like what Melanie said just now, the new length minus the original length, then you know how much it extended. And this is the one that I really want, okay, the X. Okay, I don't really want to know the L new. I want to know how much is the X. Okay, and so in talking about this, we need to fix a certain variable. Okay, and of course, in your textbook, it says the type the stiffness of the spring. But there are other factors that can also influence this one. So I'm going to give another one over here, which I want you to write. I want you to write both in your report. Okay, so dalam kamu punya, in your textbook kan, it says the stiffness of the spring, the constant variable bahkan. I want you to just jot it down, okay, put a slash next to the stiffness of the spring and write down there this one, the diameter of the spring. Ini pun perlu kena fix. We cannot change the experiment and then use different springs for different weights. Cannot. We must make sure that the spring is always the same type of spring. Okay, so either the stiffness of the spring, stiffness is kekerasan spring. Ada spring yang keras, macam motorbike punya spring, bahkan the suspension punya spring, okay, is very keras lah. Or the spring yang lembut yang macam spring pen. You know the pen, your tic tac pen, bahkan inside there got the spring, bahkan that spring is very lembut lah. You will never put that kind of spring on a motorbike lah. So that is a very, you know, that is a not stiff lah, tidak stiffness lah, keras. Okay, that spring is not very keras lah compared to the motorcycle suspension punya spring. Itu spring yang sangat keras. Okay, so the stiffness of the spring is one fixed variable. Another one is the diameter of the spring. Okay, some springs dia begini besar, and then some springs dia begini kecil. Okay, so we want to make sure that during this experiment, we are using the same type of spring with the same stiffness and the same diameter. Okay, so please jot it down and make sure that you write it in your report, which I'm going to ask you to write lah. Okay, this is our work today. Okay, let's talk about the procedure. Okay, take a look at the page 26 in your procedure, in your textbook. Okay, page 26 in your textbook. Okay, so step number 1 is already given for you. Set up the apparatus as shown in figure 1.32. Ensure that the 0 mark of the half meter rule is at the same level as the upper end of the spring. Okay, so the 0 mark, you know where the pin is over there? Can you see the pin? Yeah, so that's where the reading is lah. Okay, sorry, this is a theoretical experiment lah. The one that you're going to do on the simulation run, everything is already there lah. So you just have to put the weight and then take the reading. Okay, but we have to discuss this experiment because this is part of your experiment wajib lah. Okay, you have to know how this experiment is done, and if you ever go back to school, yeah, it's so bad of me to say this. If you ever go back to school, we will do this experiment. We have to do this experiment. Okay. So, so if you notice the spring is there, and then we put the pin over there so that you can take the reading. Okay. Now on paper, it looks very perfect kan. Okay, but I hope that you all have enough experience with our school experiments to know that whenever we do things on paper and then when we actually do it, it's not as easy as it looks lah. Okay, part of the problem is macam mana kamu mau set itu plasticine dan pin kan, and then you have to make sure that the pin is really straight. Okay, and then betul-betul ngam-ngam di ruler. Okay, it's not as easy as it looks lah. Okay, so anyway, okay, number 2, determine the original position of the pin. That is the original length of the spring. Okay, and that's where our procedure ends. After that, they cakap, plan steps to increase the force applied on the spring using the slotted weights applied and then measure the extension of the spring. Okay, so what would you suggest? Let's talk about A first lah. How would you increase the force? You know what is slotted weight? Did we do slotted weight last year? Slotted weight is like those gold colored things then kita letak yang ada cangkuk itu. You don't know what I'm talking about, slotted weights. Okay, fine. Just pretend that the slotted weights are dumbbells lah. Sama tunjuk juga, saya ada dumbbell juga. So everyone knows what's a dumbbell? Okay, this is a dumbbell lah. Okay, berhabuk lah tapi dumbbell juga lah. Okay, obviously I've never used it. So you just pretend that the slotted weights are dumbbells. Okay, so how would you, and we know that if you look at the info gallery, you need to extend the spring and then take the reading. And you have to take different force. Okay, what force is involved kalau ini kalau dumbbell? Anybody? What force is involved kalau saya letak satu dumbbell? or any weight lah, on the spring. What force are we talking about?
Weight.
Yeah, okay, it's the weight. Okay, so we cannot, how do I say, we can only have the mass, but we cannot really like, okay, we need to put 10 newtons of force on the spring. We can't do that, because how are you going to measure the 10 newtons per ton? So what you will do is you have to use different weights. Okay, so our standard is usually 5 weights lah. Sorry, 5 different masses. 5 different masses will give you, maybe you can suggest lah, you can do 20, 40, 60, 80, 100 grams. Or you can do 100, 200, 300, 400, 500 grams. As long as you have 5 different masses. 5 different masses. And then each of these mass, you need to change to the weight. Because what is our manipulated variable in this experiment?
Force.
Okay, and force is in what unit?
Newton.
Okay, so we cannot use kilogram. This experiment is force versus extension, not mass versus extension. Okay, so that means whatever mass that you use, 100, 200, 300, 400, 500 grams, okay, you have to convert it to weight for your graph lah. Okay, which I will explain in a little while. Okay, so for A, okay, for A, how you increase the force is you increase the mass. What was I saying? You increase the mass, okay, increase the mass, but for our calculation now, we have to convert the mass into weight. How do we convert mass into weight?
Times 9.81.
Okay, we times 9.81 lah. All right, so that one everybody knows lah. Okay, but we have to use at least 5 different masses. Any experiment, minimum number of readings is 5, minimum. You can do until 10 also lah. Actually, the more readings you do, the better. But standard is 5 lah. Okay, minimum 5. Okay, then how do you measure the extension of the spring? What alat do we use?
Ruler.
Okay, we use a meter rule, and then of course we measure by taking the new length, okay, the L new minus the L original. Okay, and so this is how our procedure would be lah. Okay, determine the original position, that is the original length of the spring LO. Okay, if you want to take a screenshot, you better take this screenshot now. Otherwise, if you already know how to write the procedure, go ahead and use your own words, no problem. Hang the slotted weight of 50 grams at the edge of the spring. So you hang the 50 grams over here. Okay, so the slotted weight will look something like this lah. Okay, so this is 50 grams. So saya letak 50 grams on the spring. What's going to happen to the spring? The spring is going to extend. It's very logical lah, kan? The spring is going to extend. And then you record the position of the new pin, okay, which is the L new, which is this lah. Okay, and then after that you measure the extension of the spring by calculating X equals to L minus L original. Okay, so once you're done with that, then you repeat the experiment by using slotted weights of 100, 150, 200, and 250. Okay, now if you're going to screenshot this, I want to tell you that our experiment, which I'm going to ask you to do, is not 50, 100, 150, 200 lah. Okay, it's a different, this one. But if you take a look at our this one, okay, you take a look at our jadual, first thing I need you to notice is that our mass must be in kilogram. Because kita hanya boleh kira weight kalau jisim kita adalah dalam kilogram. So please make sure that even if we use gram, make sure we change to kilogram. How do we change gram to kilogram?
Divide 1,000.
Divide.
Okay, divide by 1,000. Wow, I think okay, that was very scary because I thought it should be immediate lah, bukan like how. Okay, then after that you find this one, actually you can write it as W lah, but we write it as F because our experiment is force versus extension, so we write it as F lah. Okay, tapi sebenarnya yang kita kira adalah weight. Okay, Now L is the new reading of the L, and then L minus L original is our extension. Okay? And then after that, what kind of graph are we supposed to draw? What do you think? If our manipulated variable is force and our responding variable is extension, can you tell me what is the graph that I should draw? After I have a table, I must have a graph. So tell me what graph I should draw. What against what? Oh my goodness. Anybody?
Extension of spring
Force
against
against extension. Extension
Okay,
against
so two
force.
different. Mana satu? Extension against force or force against extension?
Extension against force.
Okay.
Extension against
According, really, yeah. Okay. Why don't you take a look at page 27? Look at figure 1.33 and 1.34. Do you see the
Force
conundrum
against
over there? Which one? 1.33 is extension against force, but 1.34 is force against extension. Okay, the book is not wrong. I'm not saying the book is wrong. The book is not wrong. The book is correct. Okay, but this is partly the reason why today there's going to be a lot of work. Okay, let me make this clear. You can jot it down in your textbook if you want. For this experiment, okay, all I want is extension against force. Because we are not calculating anything. I don't think so. Yeah. Dia cakap, okay, so extension against force. They say in the textbook, if you take a look at the results, okay, prepare a table to record the mass, okay, the force, the extended length for the spring, and the extension of the spring. So this is the table lah, okay, over here. And then they cakap, identify and plot a graph that will help you to test your hypothesis. So hypothetically lah, okay, secara teori, your graph should look like 1.33 because in this experiment, our responding variable is extension. So extension must be on the y-axis. Okay, so secara teori, your experiment, the graph should look like this lah. Okay, what kind of graph is this, everybody? Kalau dia bermula daripada kosong-kosong. What kind of graph is this?
Directly proportional.
Okay, very good. So this is a directly proportional graph. It should be a directly proportional graph. Oh no, somebody is somebody is lagging. Really proportional. Okay, it's okay. Thank you for the answer. Good answer. So this is that's all for this experiment. Okay, that's all for this experiment.